There are many revolutionary ideas that SpaceX has introduced to the space industry, and one of them is the Mechazilla system. This system is designed to catch the massive Starship and Super Heavy booster using mechanical arms mounted on a launch tower, eliminating the need for traditional landing legs. It's an engineering marvel that could significantly improve turnaround times for rocket reusability. But despite being such a revolutionary concept, it is an extremely complex and expensive system. In estimates, developing a single Mechazilla tower costs around $250 million, and SpaceX will need dozens of these towers to reach their ambitious goal of launching 1,000 rockets per year. Because of this, SpaceX has been actively exploring alternative methods to launch and land Starship more efficiently and cost-effectively. Recently, they have come up with a very interesting idea, one that could change how Starship operates in the long term. And in today's video, we'll dive into this exciting possibility and explore how it could impact the future of space travel. Before we delve any deeper, make sure to subscribe to our channel so you don't miss future updates about Starship and SpaceX's groundbreaking achievements. There have been many speculations about SpaceX's new ways to launch and land Starship, but the latest one is especially interesting. Recently, speculation about alternative landing methods for SpaceX's Starship increased after the sighting of a retired aircraft carrier near SpaceX's Starbase facility. The Mechazilla tower, currently being tested at Starbase, is designed to catch Starship and its Super Heavy booster upon return. The system eliminates the need for traditional landing legs and aims to speed up turnaround times for rapid reusability. However, catching a vehicle descending at high speeds with such precision presents a unique set of challenges. Factors such as high wind speeds, shifting weather conditions, and the potential for mechanical failure introduce risks that make Mechazilla a highly complex and expensive system to rely on entirely. A sea-based landing platform could be a viable alternative. SpaceX has already demonstrated its ability to land Falcon 9 and Falcon Heavy boosters on autonomous drone ships at sea. However, Starship is a much larger and heavier vehicle, meaning that any floating landing platform would need to be significantly stronger and more stable than the drone ships currently in use. Given that an aircraft carrier was designed to handle heavy loads, high-impact landings, and extreme ocean conditions, a similar vessel could theoretically serve as a landing site for Starship. A floating platform for Starship landings could work in several ways. One possibility is retrofitting a decommissioned aircraft carrier or building a custom platform with reinforced landing surfaces. This would allow Starship to land vertically, using deployable legs similar to Falcon 9. The advantage of this approach is that it would provide a solid and stable surface for landing, reducing the risks associated with precision catching. If the platform is large enough, it could even accommodate multiple Starship landings in a single operation, potentially increasing launch frequency and efficiency. Another approach would involve installing a Mechazilla-style catching system onto a floating platform. This would allow SpaceX to maintain Starship's legless design while positioning the catching mechanism in international waters, far from populated areas. A floating catch system would need to be significantly more robust than the current Mechazilla at Starbase due to the instability of ocean conditions, requiring advanced stabilization systems to counteract wave movements and high winds. However, if successful, it could provide a scalable solution that eliminates the need for multiple expensive land-based towers. On the other hand, an alternative to the complex Mechazilla system is simply adding landing legs to Starship and landing it on solid ground, much like Falcon 9 and Falcon Heavy. This would simplify the landing process and remove the need for a precision catch mechanism, reducing the chances of catastrophic failure during landing. However, Starship's sheer size and weight make this approach more complicated than it might seem. Starship stands 50 meters tall, while the full stack with the Super Heavy booster reaches an incredible 120 meters, making it the tallest rocket ever built. Its weight is another major challenge. Starship alone has a dry mass of around 120 to 150 metric tons, while a fully fueled Starship can weigh over 1,200 metric tons at liftoff. The Super Heavy booster, responsible for the initial thrust to orbit, has a dry mass of approximately 200 metric tons and, when fully fueled, weighs over 3,500 metric tons. This immense weight means that any landing legs would need to be incredibly strong and lightweight to support Starship without adding unnecessary mass that would reduce its payload capacity. Another issue with adding landing legs is the impact upon touchdown. Falcon 9's legs work well because they absorb the shock of landing with a relatively lower thrust-to-weight ratio, but Starship would require a much larger and more robust leg system to distribute its weight evenly. SpaceX previously experimented with different leg designs during the Starship prototype phase, but ultimately decided against them in favor of the Mechazilla catch system, which allows for immediate reusability and removes the risk of uneven terrain causing a failed landing. Landing on land would also require designated landing zones with reinforced concrete pads capable of handling the massive weight and heat from the Raptor engines. The 33 Raptor engines on Super Heavy produce over 7,590 metric tons of thrust, creating extreme stress on landing infrastructure. A sea-based landing platform, on the other hand, could absorb some of this force through water displacement and specialized damping systems, making it a potentially safer and more practical long-term solution. One of the primary advantages of a sea-based landing system is safety. By moving Starship landings offshore, SpaceX could significantly reduce the risk of accidents near populated areas. In the event of a failure, the vehicle would crash into the ocean rather than over land, minimizing damage to infrastructure and reducing potential regulatory hurdles. Another major advantage is improved fuel efficiency. Currently, Starship must perform a costly boost-back maneuver to return to its landing site. A floating landing platform positioned in the right location could allow Starship to land without expending additional fuel for a return trip. This could lead to an increase in payload capacity, making missions more cost-effective. A floating landing platform would also provide increased flexibility. Unlike a fixed launch site, a mobile platform could be relocated based on mission requirements. For example, SpaceX could position the platform closer to the equator for more efficient geostationary launches. This mobility would also allow for more frequent launches without congestion at land-based facilities. Beyond landings, a floating platform could also serve as a launch site. SpaceX has previously explored offshore launch concepts with the oil rigs Phobos and Deimos, which were intended to be converted into floating Starship launch platforms. While these rigs were eventually sold, the idea of launching Starship from the ocean remains relevant. Launching at sea would provide many of the same advantages as landing at sea, including safety improvements, reduced regulatory constraints, and optimized launch trajectories. Additionally, a floating platform could play a crucial role in Starship logistics. With Starbase and Kennedy Space Center expected to be the primary hubs for Starship production and launch operations, efficiently transporting vehicles and components between these locations will become increasingly important. A carrier-sized vessel could serve as a mobile shipyard, capable of transporting multiple Starship prototypes and boosters at once. This would be particularly useful in the event of production delays or supply chain disruptions, allowing SpaceX to maintain a steady launch cadence. That's all for today's video. Thanks for watching, and stay tuned for more updates on SpaceX and Starship.